In the chapter Light, now we study about eyepieces. What is an eyepiece? What is its function? What are the eyepieces about which we are going to study? What is its construction? What is the construction of each? What is the working of each? What are the advantages and disadvantages with each of the eyepieces? Eyepieces. Eyepieces. In telescopes and microscopes, we use lens system for observing the image called eyepiece. Eyepiece is a lens system. Generally, there will be two lenses in this system. Two lenses will be there in this system. One of them will be placed towards the objective of the instrument. Such a lens is called field lens. Field lens will be towards the objective of the instrument. Another lens will be used to observe the image. So it will be towards the eye. The lens towards the eye is called the eye lens. Field lens increases the field of view. Field lens increases the field of view, whereas eye lens magnifies the image. The image will be magnified by the eye lens. The field of view will be increased by the field lens. We study about two eyepieces, namely Ramsden's eyepiece and Huygens eyepiece. Ramsden's eyepiece. Ramsden's eyepiece. There are two plano-convex lenses in a Ramsden's eyepiece. It consists of two plano-convex lenses of same focal length f. The two lenses will be placed coaxially. The two lenses will be placed coaxially at a distance 2 by 3f, 2f by 3. Moreover, the curved surfaces will face each other. The curved surfaces of the two lenses face each other. We fix cross wires. Two thin wires perpendicular to one another will be fixed at a distance of f by 4 from the field lens in front of one of the lenses, that is known as field lens. At a distance f by 4, cross wires are fixed. These two lenses together act as a single lens. These two lenses together act as a single lens called eyepiece. That single lens focal length will be 3f by 4. So these two lenses together equal to a single lens of focal length 3f by 4. That is known as its equivalent focal length. Working of Ramsden's eyepiece. Working of Ramsden's eyepiece. In this figure, the objective is at the left side and the rays will converge at the point I1. The rays coming from objective, they converge and form the image I1 at a distance f by 4 from the field lens. I1 is the image formed by the rays coming from the objective. So it is the image of the objective. It will be formed at a distance f by 4 from field lens. This image I1 acts as object for field lens. The object of field lens is I1. This object I1, the rays coming from this object, they fall on the field lens. They fall on the field lens, and after refraction in the field lens, they move towards the eye lens. They travel towards the eye lens. These rays appear to be coming from a point I2. Hence, a virtual image I2, is formed to the left of the field lens, and its distance will be f by 3 from field lens. The distance of the image formed by field lens is f by 3, and it is a virtual inverted image with respect to the object. Then the rays which are refracted through the field lens, they fall on the eye lens, and refraction takes place once again. We can consider this image I2, the image formed by field lens, as the object of eye lens, and the final image will be formed at infinity. The distance of this f2 from the eye lens is f, hence the rays coming from this object can be considered as though parallel rays, and the final image will be formed at infinity. The final image is inverted and large in size. Let us observe the image formation once again. I1 is image by object 2, and it is at a distance f by 4 from field lens. It is real and inverted. It acts as object for the field lens, and an image will be formed by the field lens. That image is I2. It is virtual and inverted. This is at a distance f from the eye lens. So this I2 acts as object for eye lens, and the final image will be formed at infinity. It is virtual and inverted. Advantages and disadvantages of Ramsden's eyepiece. Ramsden's eyepiece is a positive eyepiece. We can measure the images. With this eyepiece. Whenever we want to measure the image, we use this eyepiece. Since the image of object 2 is formed in the focal plane of the field lens, the magnification of the image and crosswires are equal. Since the image is formed at the crosswires, the magnification of both image and crosswires are equal, so measurement becomes easy. In this eyepiece, spherical aberration is minimized, though the condition for elimination of spherical aberration f1 minus f2 is equal to d is not satisfied in this eyepiece. This condition is not satisfied in this eyepiece, yet the spherical aberration is minimized. The condition required for elimination of chromatic aberration in case of two lenses is not met in this eyepiece. It is not also satisfied in this eyepiece, but the aberration is minimized. Though the condition f1 plus f2 by 2 is not equal to d in this eyepiece, this aberration is also minimized. Another advantage of this eyepiece is the field of view of this eyepiece is very, very high. The field of view is very, very high in this eyepiece. Huygens eyepiece. First, let us study the construction of Huygens eyepiece. The Huygens eyepiece consists of two plano-convex lenses, but the focal lengths of these two lenses are different. The focal length of eye lens is f. The focal length of field lens is 3f. Field lens is of 3f focal length and eye lens is f in focal length. The separation of these two lenses is 2f. They are arranged coaxially in a metallic tube. They are arranged coaxially in a metallic tube with the curved surfaces of both the lenses facing the incident rays, facing the object to the incident rays. This is a negative eyepiece. The equivalent focal length of this eyepiece is 3f by 2. 3f by 2, that is the equivalent focal length of this lens. These two lenses can be considered to be of a single lens of focal length 3f by 2. Working of Huygens eyepiece. Working of Huygens eyepiece. The incident rays coming from the objective, here in this figure from left side, they will converge to the point I1. Actually, they would have formed the image at I1 had there not been the field lens. In the absence of field lens, the rays coming from the objective, they would have formed the image I1. But because of field lens, refraction takes place and the image will be formed at I2. Because of the field lens, the image will be formed at I2. Now, the image I1 is a real inverted image. I1 is a real inverted image. Here, we can consider I1 as the object for field lens. We can consider I1 as the object for field lens, and thereby the image I2 is formed by field lens. So, the object is virtual object for field lens and the final image I2 is a real image. It is also inverted and real. This image I2 acts as object for eye lens. Actually, the rays refracted from the field lens, they pass to the eye lens, and once again refraction takes place in the eye lens. And the final image will be formed at infinity. But we consider I2 as the object for eye lens and the final image is at infinity. It is virtual, inverted. It is virtual and inverted. In a nutshell, let us recollect the working of Huygens eyepiece. I1 is the image formed by the objective. It is real and inverted. It is at a distance of 3f by 2 from the field lens or f by 2 from the eye lens. It is at 3f by 2 from field lens or f by 2 from eye lens. It acts as an object for field lens. Really, it acts as virtual object for field lens. An image I2 is formed by the field lens. It is real and inverted. It is formed at a distance f from both the lenses. It is at a distance, I2 is at a distance f from field lens as well as from eye lens. It acts as object for eye lens and the final image is formed at infinity. The advantage of this eyepiece is the image will be very clear because both the aberrations are almost eliminated. The conditions required for spherical aberration and chromatic aberration are met in this eyepiece. Both the conditions are satisfied in this eyepiece because f1 is equal to 3f and f2 is equal to f. Therefore, f1 minus f2 is equal to 2f, which is the actual distance between the two lenses. This is the condition required for the elimination of spherical aberration. So the condition required for spherical aberration is met, and also the condition for the elimination of chromatic aberration is also met. That is, f1 plus f2 by 2 is equal to d. 3f plus f by 2 is equal to 2f. Hence, the condition required for elimination of chromatic aberration is also satisfied in this eyepiece. Hence, chromatic aberration is completely eliminated and spherical aberration is almost minimized. Another condition required for elimination of chromatic aberration is the curved surface should face the incident rays. So, spherical aberration is almost minimized and chromatic aberration is completely eliminated. The disadvantage of this eyepiece is, we cannot measure the images. We cannot measure the images with this eyepiece.